Assalamualaikum and good evening. Okay, now we will discuss our first assignment. Let me introduce myself first. My name is Muhammad Khushaini bin Kamar Zaman and my metric number is 213141.
Hi, my name is Muhammad Syafiq bin Ruslan, and my metric number is 210483.
Hi, my name is Nur Hamizah binti Safi and my metric number is 212187.
Syazleen?
Hello, my name is Athirah from Izzati and my metric numbers is 212648.
Hi, my name is Syazleen Noor and my matrix number is 212134.
Okay, so let's move on to the our ni. Uh, updating our progress by each task. Okay, first we start with introduction. Is that your part, Izzati? Okay. Do you have anything to say?
I think so far no. Maybe we can start the introduction first.
Okay, for introduction part is my part.
Oh, okay, sorry.
Okay, for the introduction, I write about what is engineering at first and then relates it to the task that assigned to our group, which is to find a real engineering application from any resources that related to numerical solution. Numerical solution method is Euler's or Runge-Kutta. So, from the resources we have looked for, we decide to use Euler's method to solve our problem. And then, in the introduction, I'll tell what is Euler's method because we choose to use Euler's method. That's it.
Mm-hmm. So in the introduction, did you include the what the beneficial of using Euler instead of RK, Runge-Kutta?
Yeah, that's it. True.
Mm-hmm. Alright. Anyone wanted to add something about introduction? Okay, so if not, we continue with the engineering problem. Shazlin?
Yes, for engineering problem, as we know that Euler's used to solve the ordinary differential equation, right? And actually, there are many applications in engineering that can use Euler's and Runge-Kutta method. And I found that in civil engineering that it is helpful in estimating the force deformation behavior in the nonlinear equation. Sorry, nonlinear range. That is for the civil engineering. And also, I found that Roche-Kutta method are applied to calculate a beam supported by spring and a four bar mechanism also use the range Kutta method to come to calculate that. And also the robotic manipulator that with collocated control. And there's also the example for electrical engineering. And for this electrical engineering, it uses Euler's method. It is about the series and the parallel circuit. Actually, this one is quite complicated, so I try to find another one. And I found that the industrial engineering is better, which is it is about the open loop response. Open loop response is the combined response of the plant and the controller, excluding the effect of the feedback loop. That's what I found, and also what more. So far from what I have found, this example that open response loop open loop response is the best one to choose. Yeah. And I look up for some example questions because there are many questions and there's the complicated one, there's also the simple one. But for the one that related to the industrial engineering, both method are used, which is ULIS and Roskuta. So we can choose either to use the Roskuta or ULIS. So I just want to ask your opinion because I would prefer ULIS actually. So I don't know if you guys want to use the Roskuta. So what you guys think?
Actually, like you mentioned before about the mechanical application one, I found out it also quite complicated because the equation is so long, so it's hard if just I'm concerned we make a small mistake, like we uh, substitute the wrong value, something like that, and maybe that's why we chose the electrical one.
Okay then. So we just go on with the ULIS method, right?
Yes.
Yeah, that's all for what I have found so far. Yeah.
I want to add something about the RK method, the the mechanical one. The step also about 3 to 4 pages, so it's not suitable with our assigned task, which is we only need to do the 5 pages for the report.
Yes, that's right. I agree.
Mm, okay. Then have you mentioned?
Can
Uh,
I add something?
yeah, sure.
Okay. As Syazleen mentioned that about actually I prefer to choose a Lewis method since we already discussed before that between we want to choose between industrial or electrical application, right? And I prefer to take the industrial because I already found the problem that's suitable to this application, which I think is more simpler and easy to understand. So I think it's better to choose this method instead of architecture.
Yes, RK.
Yes, yes, I agree with that.
Um, all right. Anyone want to add something? Okay. So, Shazlin, have you mentioned the problem that we will solve?
Oh, do you mean that the sample of the question, sample example for the questions?
No, the question that we have to solve for the report.
Oh, actually, I have found that like I think it's the same from what Izzati said just now. I think we found the same question because I think we have discussed about that question before. I discussed it with her, and I found the question about the industrial engineering, which is about the operation loop just now I mentioned.
Okay.
And the
Alright.
question is not quite complicated, so I think we can choose that one.
Okay. So, I think we need to change the step size. Like the question that we have found, it use 0.4 second, right? So I think we change to 0.1 to make the graphical graph more accurate. Mm.
Sorry, but I think how about we change it to 0.2.
Sure
I
can,
make
but the smaller the number,
or
we will get
you
more
want to make
accurate.
okay, okay. So what the other thing, do you guys okay with 0.1 or oh,
I think it's okay.
Yeah, I agree to make it 0.1.
Alright, so we now already 10 minutes. We move on to numerical method. Izzati.
Okay. For me, as I mentioned before, I have searched for the problem. Can you hear me?
Sorry.
Yes. And I continue.
Ah yeah, sure.
Okay, for numerical method, as I mentioned before, I have choose several questions, and I think the industrial engineering application is the problem for this application is the most suitable because in this problem we only need to find the speed of an open loop response, which in this problem it already given the time and the step size, also the equation that we need to use for this for the user's method. And in this solution, we only need to derive the equation given for the system and to obtain a differential equation, and then we use the user's method formula to find this system and substitute the time and step size given in this problem. And I think that's all for numerical method.
Alright, now I will continue with my part, which is analytical method. Uh, and also analytical method is well known as preferable, more preferable compared to numerical one. So my progress, if I have done the calculation and like the equations given, we need to rearrange it to get the more simplify one lah. And then after rearrange, I found I find the integrating factor and multiply for both side with the rearrange equation 1, and then I integrate both side to get the uh, term C, which is we substitute the given condition, and then we get the C value, and with the C value we substitute back into the equation, and we substitute the step size, which is the H, into the term T, and then we find each W value for the each substitution lah. mm, and I think that's all my progress. Next we move on to comparison.
Alright, for the comparison, I think it's quite simple. After I obtain the data from Izzati and Khushaini, data from the numerical user's method and analytical method, I believe that there will be difference between the data. Then I will put the obtained data in a table, and then we'll compare it to know which one is has much more bigger error percentage. Then once I complete the table, I will make one graph, and from the graph we can view the how big the difference is actually between the Euler's method and analytical method. So that's all for comparison. We can move to conclusion.
Okay, from for the conclusion part, uh, I write about um, after we compare, and then I tell about the, uh, the value from the numerical method solution and analytical method solution. That's it.
Okay, actually for my part, I forgot to mention something. The method that I use for analytical method, since analytical method can we can use many many formula, but I just solve with the normal ODE solution, which is find the integrating factor. And then also my job scope is to put the calculation into Excel and make graphical graph. And for that part I have not done yet. mm, that's all my progression. So anyone have something to say?
I have nothing to say.
Okay, Izzati. Hamizah.
I think I have no more to say. That's it.
Okay, next Syazleen.
Um, Actually, I am curious about something about the Excel you mentioned just now.
Mm-hmm.
Do we have to do it for? Is it for analytical, right? Or
Yes,
the
for analytical.
numerical?
It just so that we can see the behavior of the graph. Means if we take a look at the behavior, then we can evaluate lah our
Okay.
our solution. Okay, so if no, then we end our discussion here. uh that's all. Thank you.
Thank you.
See you
Thank you
guys.
all.